Okay, hi. In this video, I'm going to show you how QQ plots work and how to use them using this here app. There's a link in the description. First, I'm just going to hit simulate here and just show you really quickly what all it does. For those of you who know how QQ plots work already, I can keep hitting simulate and it'll crank them out. Over here on the left, we have a normal distribution, but we can mess around with skewedness and with tail length and then simulate again, and I can mess around with sample size as well and make that happen. Okay, that's all it does. I am now going to explain what's going on here. So, a QQ plot is a tool for comparing the distribution of your data to some other distribution. So, usually a normal distribution. In this case, that's what it is. Um, and what we have, well, in this app, what we have is plot over here. There's a normal distribution superimposed. There's a histogram of the data that we just generated. Every time I hit simulate, it makes some new data, and we know that these data came from a normal distribution because I've zeroed out the skewedness and tail parameters here. Um, okay, so what's going on over here in this plot? The x-axis is labeled theoretical quantiles. The y-axis is labeled sample quantiles. A quantile is like a generic form of a percentile. Percentiles chop your data up into 100 chunks. Quantiles chop your data up into however many chunks you want. And on a QQ plot, it chops it up into the number of chunks that's equal to your sample size. I'm going to take the sample size down to 10 because that'll make this easier to explain. I'm going to hit simulate. Okay, and I can do this over and over again. And I want you to notice if you sort of just look at the horizontal position of these data points, they stay the same every time I hit this. Let me just point this out. So I'm just going to mark on the horizontal axis here about where these points lie. And what you might notice is that they're more clumped together towards the middle and they're more spread out towards the ends, and that's because under a normal distribution we expect our data to be more clumped up towards the middle and more spread out towards the ends. And what this axis is actually showing is where you would expect your data points to lie if they followed a perfect normal distribution. So there we go. I'm going to take that away and hit simulate again, and then I'm going to bring it back and check that out. The little green dots I drew are still underneath the data points. Let's do that one more time. Here we go. Okay, so there you go. So this horizontal axis, the position of the data points on the horizontal axis is determined completely by the sample size. They're just placed where they ought to be if they were following a normal distribution. And you can and again, uh, they're packed in towards the center here because the data are supposed to be packed in towards the center, and they are more spread out on the ends because the data are supposed to be more spread out on the ends. Okay, so that's the horizontal axis. On the vertical axis, we have sample quantiles. This shows the distribution of your actual data, where your data points fall relative to one another. Here the numbers on the y-axis are the same as on the x-axis. Sometimes that doesn't always happen. These are standard deviations from the mean, is what you're seeing here. So I'm going to hit simulate again, see if I can get a good one that's nice and easy to explain. I don't like that one as much. Let's see. I'm looking for something. I'm looking for something that has some obvious. Okay, this is pretty good. Um, Okay, as with before, we've got the data points spread out on the horizontal axis the way they ought to be if they came from a normal distribution. On the vertical axis, what's going on here? You see these are like almost perfectly lined up with each other. Um, and they're sort of like above the line there. And then and here these are out. So what's going on? Well, what this is showing, you see this is -1, this is +1. So -1 corresponds to the left side of this. +1 corresponds to the right side of it. What it's showing is that on the left side here, these data basically don't have a left tail. They're all hanging out over here around where -1 would be. But on the right side, they're a little bit more spread out. Um, I'm gonna up the sample size to 100 because that's also a nice number for explaining stuff. Let's see if I can get it there using my mouse. 99. Okay, there we go. 100. I'm gonna hit simulate. Um, you may be familiar with the what some people call the empirical rule, or the 98 or 68, 95, 99.7 rule. We see it here on Wikipedia. What it says is that if your data follow a normal distribution, then 68% should be within a single standard deviation of the mean. 95% roughly should be within two standard deviations of the mean. It's actually 1.96 standard deviations of the mean, but let's not worry about that. And then about all of them should be within three standard deviations of the mean. Okay, so I generated 100 data points, and so if we look again on this horizontal axis, what we're showing here is that this should be like 68% of the data. Something like that. And then you should have about 95% of the data. And here, hey, look, it's showing 4 out of 100 values past negative and positive 2. The real cutoff is 1.96. So that is about right. And then what you can also see over here is that like this looks pretty close to a normal distribution, and what that gets you is these data points all being pretty close to this diagonal line. The diagonal line represents the actual distribution of your data falling at about where it ought to be if it was a perfect normal distribution. Let's mess it up. So the actual point of this app, when students are learning QQ plots for the first time, usually you see still pictures in textbooks and they show you little shapes and you're like, here's how you interpret it. So this whole time I've been drawing data from a normal distribution. I'm doing this right now. Ooh, that was a good one. Just to show you like how much variation you can get even when your data actually come from a normal distribution. So, here we go. These up here, yeah, they're off the line. That's off the line. We always see these things off the line more towards the ends because the ends are where the tails are, and it takes a much bigger sample size to fill out the tails properly than it does to fill out the middle properly. So you're always going to see these things veering off a little bit towards the ends. Here they seem to veer off a lot, but I know these data came from a normal distribution because that's how the app works. If I crank the sample size all the way up, now what you'll see is this behaves much better. The data are almost perfectly on the line in the middle, and not too far off of it on the ends. Okay, so let's see what happens when I mess with this stuff. So what I can do is I can take this normal distribution and mess it up. I can skew it left. I can skew it right. Let's do that. I can also give it heavier or longer tails, or lighter or shorter tails. I'll make it a slightly heavier tail. I'll hit simulate, and this is going to be really obvious here. Okay, so let's see. We've got this extreme right skewedness. We've got most of the data here, but they're really spreading out quite a bit. And how does that appear up here on the QQ plot? Well, we've got this sort of a shape, and you could just memorize the shape, but let's see if we can understand it. Here we see that the data points are very close to each other on the vertical axis, showing sample quantiles, and this is below 0, so this is the negative side. So what this shows us, see how they're all lined up really nicely there? This shows us that they're really close to each other on the left side. But then up here, we see this veering away from the line. So all of these plots are above this diagonal line, meaning that they are more spread out on the right side than they ought to be if they came from a normal distribution. If they came from a normal distribution, they'd be on this line, but they are further away from it in the vertical direction, which tells you that this is right skewedness. Let me go ahead and switch the side. Here, we'll do left skew, and there you go. Now this is just switched. So now in the vertical direction, you see on the top end, on the positive end, these data points are all like almost on top of each other. Well, that's right there. And then on the left end, you see they are further away from the center, further away from the line than they should be. So like these values over here, these are the fact that they're like visually below the line in this case means that they are farther away from the middle than they should be if they came from a normal distribution. Those refer to what is going on over there. So that's how that works. The remaining thing that I want to point out is how obvious this is when the sample size is large and how unobvious it is when the sample size is small. I suppose these, okay, how about that? I mean, we can look, oh, whoopsie. We can look over here and see that that doesn't look fantastic on the histogram. This thing right here, man, this looks not too dissimilar from the plots we saw when we knew that it was a normal distribution. Let's bring the sample size down a little bit, and maybe we'll make this the skewedness a little bit less severe. Okay, here you go. Oh man, look at that. If I was just looking at this QQ plot, there's no way I would presume that this came from a left skewed distribution. They're so close to the line. Yeah, maybe they're off a little bit on the top, but let's remind ourselves of what we very often see when we know that the data came from a normal distribution. Simulate here. Yeah, you know, they're off the line. They're never going to be exactly on the line. So, oh, look at that. Hey, is that a weird thing? Well, I know it came from a normal distribution, so it shouldn't be. Let me make this thing get skewed right. Actually, you know what? Let's do heavy tails really quick. I haven't shown you that. Heavy tails is sort of like skewedness in both directions. You could say, okay, well, I've got this big one out there, but uh, boy, I don't know. So that one's maybe a little bit more obvious. The lesson here is that um, making a determination as to whether your data appear to have come from a normal distribution is far easier when the sample size is large than when it's small. QQ plots are a great tool, but at some point there's a judgment call, and yeah, when the sample size is small, data that came from a non-normal distribution that looks a lot like data that came from a normal distribution, that is what we have to deal with. Okay, I hope that was helpful. Again, there's a link to this in the video description. I've got other videos of other apps teaching statsy things as well, and I'll see you on one of the other ones.